video, I want to look at the idea of confidence intervals. In particular, I'm going to be looking at confidence intervals where we know the population standard deviation. The idea of a confidence interval is to help us move from a sample to a population. And instead of giving a specific value for the population, we give an interval estimate with the idea that ideally, the true value of the parameter, the true value of the population, should be somewhere within that interval. Here's the general formula to calculate a confidence interval, and I want to look at a few things about this. First off, we do have the term x bar, that's our sample mean. Sigma, this is our population standard deviation, and n, this is our sample size. But we also have this variable z star. This comes from our confidence level. This table gives the most common values of z star used. For a confidence level of 90%, z star will be 1.645. For a confidence level of 5%, z star will be 1.96. And for a confidence level of 99%, z star will be 2.58. The other thing to point out with this is that the left and the right-hand side of this only differ by a sign. On the left, there's a minus sign, and on the right, there's a plus sign. So this piece, z star, sigma, divided by the square root of n, that I'm adding and subtracting from both sides, this is known as the margin of error. As we calculate this, our first step is going to be to find this margin of error. Then we'll add and subtract it from the sample mean. That'll give us our confidence interval, and then we'll be able to interpret it. So let's look at examples of how I can use this formula and how I should interpret the solutions that I get. In a study of 40 high school students, the mean number of hours per week that they played video games was 20.7. The standard deviation of my population is 3.2 hours, and I want to find a 90% confidence interval of the mean time playing video games. Let's start by seeing what information we have. We do have 40 high school students. That'll be my value of n, my sample size. We also know their mean was 40.7. That'll be my x bar. And we know this population standard deviation is 3.2. That will be my value of sigma. We're also looking for a 90% confidence interval, so that'll give me my value of z star. Condensing this information, I have n equal to 40, x bar equal to 20.7, sigma equal to 3.2, and z star equal to 1.645. The first thing I'm going to look for is the value of my margin of error, which I'm going to denote as MOE. This was z star times sigma divided by the square root of n. Plugging in my values for z star, sigma, and n, and then calculating, I get that the margin of error is about 0.83. Then, to calculate my actual confidence interval, I'm going to do x bar minus 0.83 and x bar plus 0.83. Plugging in my value for x bar, and then simplifying, I get that the true mean is somewhere between 19.17 and 21.53. To interpret this, what I'm saying is that the true number of hours per week that high school students are playing video games is somewhere between 19.17 hours and 21.53 hours. And I'm 90% confident that that is correct, that the true mean will actually be between these two values. Let's repeat this problem one more time, but this time, let's do a 99% confidence interval. Since the only thing I changed is the confidence level, the only thing that changes is the value of z star. A 99% confidence interval will correlate to this 2.58 value of z star. When I use these values to calculate my margin of error, z star sigma divided by the square root of n, and I go ahead and plug in my values and simplify, I get 1.31 for my margin of error. So this time, I'm going to do x bar minus 1.31 and x bar plus 1.31. Plugging in my value for x bar and then simplifying, I get 19.39 is less than mu is less than 22.01. This tells me that the true number of hours that students or high school students are spending playing video games is somewhere between 19.39 and 22.01 hours. And this time I'm 99% sure. I'm 99% confident that the actual true value is somewhere between these values. By moving the confidence level from a 90% to a 99%, I've basically widened the interval. I've given myself more room for my true mean to fall into. So when we increase our confidence level, it makes our interval wider. It gives us a bigger range to kind of capture that true value of the mean.